Good morning, dear students. In this video, I'll be discussing the solution of certain problems from the topic triple integrals. So first we have problem number 4. Our question is, find the volume of the tetrahedron with vertices 0, 0, 0, 1, 1, 0, 0, 1, 0 and 0, 1, 1. So we have to find the volume of the tetrahedron whose vertices are these 4 points. So first let us sketch the tetrahedron D with vertices 0, 0, 0, 1, 1, 0, 0, 1, 0 and 0, 0, 0, 1, 1. And then we'll be sketching its shadow R. So let us see first what are our vertices. So our vertices are 0, 0, 0. If this is our origin, let this be x-axis, this be y-axis and this is our z-axis. And suppose this point is 1 on the y-axis and this point is 1 on the x-axis and this point is 1 on the z-axis. Then we get that our points, then we get that this particular point is 0, 1, 1. This particular point is 0, 1, 0 and this particular point is 1, 1, 0. So we know that these are the vertices of the tetrahedron. So we will be joining all the vertices now. So we know that this is the shape of the tetrahedron. So we are joining these vertices and we will get a tetrahedron. So now this is our region. Now we have to find the equation of this upper plane and we have to find some equations. Okay. So let us see first. So this is our region. So this is our region and we have to find the volume of this region. So first we know the formula. We have the volume formula as V is equal to the volume of the given tetrahedron is capital V is equal to triple integral dz dy dx. So this is our formula to find the volume. And now we will be evaluating this triple integral to find the volume. So first we can see that to evaluate this volume, we have to know the limits of integration. So here we don't know the limits. This is the order of integration and we have to find the limits of integration. So first you have to find the limit of z, then you will be finding the limit of y and then we'll be finding the limit of x. So we have a procedure. First we have to find the limit of the variable z. So to find the limit of the variable z means we will be considering a line passing through this region parallel to z. So this is our line passing through our region parallel to z. Now observing this line M, we will be getting the limits of z. So we see that this line M touches this region at mainly enters this region at this point and exits our region at this point. This point is a point on the plane, on this plane, a point on this particular plane. So we have to find the value of z at this point and at this point to get the limit of z. So we know that we haven't find any equation for this particular plane. So we can see that this particular plane is the plane containing these 3 points. So we will be using an equation of finding the plane containing 3 points. So, so here all we know is the 3 points the plane contains 0, 0, 0, 0, 1, 1 and 1, 1, 0. So the equation of this particular plane containing these 3 points, we can find the equation by the formula this. It is known that the equation of the plane through the points x1, y1, z1, x2, y2, z2 and x3, y3, z3 is determinant x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1. So in this particular formula, instead of the 3 points, here it is x1 y1 z1 x2 y2 z2 and x3 y3 z3. So we have to basically substitute these three values 0 0 0 0 1 1 and 1 1 0 in this particular equation, and evaluating, simplifying, finding the determinant of this particular value, we will be getting the equation of this particular plane. So by using the formula I have told now, we will be getting that the equation of this particular plane is z equal to y minus x. So we get that the equation of this plane is z equal to y minus x. So from we get that at this point the value of z is y minus x. So our limit of y is from z equal to 0 to z equal to y minus x. So we get the limit for the variable z. Now we have to find the variable for other variables. So to find the limits for the other variables, we have to see now what is the order. So first we have found the limit of z. Now we have to find the limit of y and z, y at x. So to find the limits of integration for y and x, we will be projecting our region onto yx plane or xy plane. So here we can see that our region is already touching the xy plane. So this particular region will be the shadow of the region on the xy plane. Here our region is already touching the xy plane, so we don't have to particularly find the shadow. It is already the intersection of this region with the xy plane. So this is the shadow here. Now observing at this region, shadow on the xy plane, we can find the limit of x and y now. So first we have to see which variable we have to find. So here we see that first we have to find the limit of y. So considering this region, now we'll be finding the limit of y and x. So we see that we will be considering this region, and to find the limit of y at y, we will be considering a line parallel to y in this region, passing through this region, and we will be observing this line and finding the limit of y. So we see that this line enters this region at this point, exits the region at this point. So the value of y at these 2 points will determine the limit of integration for y, the variable y. But we can see that we don't know what is the value of this particular line and this particular line. So first we have to find the equation of these two lines. Only then we can find the limit of y. So here to find the limit equation of this line and this line, all we know is that this line passes through these 2 points 0 0 0 and 1 1 0. So equation of the line passing through 2 points, we'll be using that particular formula. So we already know an equation of the line joining 2 points x1, y1, z1 and x2, y2, z2 in a three-dimensional space is x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. So we'll be using this particular formula here. Here x, we are having 2 points. This is x1, y1 is z1. This is x2, y2 is z2. So we'll be substituting these 2 points in our said equation, and solving, we get that equation of this line is y equal to x. Similarly, here also if we have to find the limit of this equation of this line, we know that this line passes through these 2 points 0 1 0 and 1 1 0. So the equation of the line passing through these 2 points, here also we will be using the same formula. So by using the same formula, we get that x equal to 0, y equal to 0 and y is x equal to 0, z equal to 0 and y equal to 1. So the equation of this line will be y equal to 1 and the equation of this line is y equal to x. So we see that at this point the value of y is equal to x and at this point the value of y equal to 1. So our limit of y is from y equal to x to y equal to 1. Now by observing this particular line again we'll be finding the limit of x. So we see that this line L covers this region when we shift this line from this point to this point to this point. So when we shift this line from this point to this point, this region L covers this R. This line L covers this region R. So we know that at this point the value of x is 0. At this point the value of x is 1. So we get that the limit of x is from 0 to 1. So we get the limit of x is from 0 to 1. So now we have obtained the limit of integration for all the variables x, y and z. We will be substituting it. Here first we will be substituting the limit of z, that is from 0 to y minus x. Then you will be substituting the value limit of y from x to 1 and limit of x from 0 to 1. So now we will be evaluating this triple integral. First we will evaluate this integral. So here we see that here it is integral dz. Integral dz is z and first we will be evaluating this. So we will get integral 0 to 1, integral x to 1 and integral dz is z. And putting the upper limit minus lower limit we get y minus x. So we get that integral x to 1 dy dx. So in the next step we'll be here evaluating with respect to y. So we'll be evaluating when we are integrating with respect to y, we'll consider all other variables as constant. So we get integration as 0 to 1 y square by 2 minus x into y and limits are from y equal to x to y equal to 1 dx. The next step we'll be putting the upper limit minus lower limit. So putting the upper limit we get 1 by 2 minus x square by 2 plus x square dx. So after this next we'll be integrating with respect to x. Then we get x by 2 minus x square by 2 plus x cube by 6 limits from 0 to 1. So putting the upper limit minus lower limit we'll be finally getting 1 by 2 minus 1 by 2 plus 1 by 6, that is 1 by 6. Now next we have problem number 5. So our question is, rewrite the integral in problem number 4 as an equivalent integral in the order. So in question number problem 4, we have evaluated the volume V is equal to triple integral dz dx, dz dy dx. So here we have to change the order and evaluate it. We don't have to evaluate it only, we have to change the order and we have to write it properly. So our figure is the same as we had done earlier. So this is our figure. So it is same as we have done earlier. So first let us see the first order. The first order is dz dx dy. The second order is dy dz dx. Third dx dy dz. So this is our figure as we have already discussed in problem number 4. Now here in first part we have to find the limit of z first. So to find the limit of z first we have to so here in the first question, first subpart, we have to find our integral is triple integral dz dx dy and we have to properly write this integral. Only we have to write, we don't have to evaluate it, we have to only write properly the limits and everything. Then here we see that first we have to find the limit of z and then you will be finding the limit of x and y. So First we have to find the limit of z. So for that we'll be considering a line passing through this region parallel to z axis. So this is the line passing through our region. So we see that this line touches, by observing this line we will be getting the limits of z. So this line touches our region at 2 points, precisely at this point and at this point. So the value of z at these 2 points will determine the limit of z. So we know that this point is a point on the xy plane. So any point on the value of z on a xy plane is always 0. So here the value of z is 0. Here this point is a point on the plane z equal to y minus x. So this plane equation is z equal to y minus x, and it is a point on this plane, and so we get here the limit of value of z is y minus x. So we get the limit is from 0 to y minus x. So the limit of z is from 0 to y minus x. 0 to y minus x. Now next we have to find the limit of x and y. So to find the limit of x and y, we will be projecting this region on the xy plane. So here, as we had discussed in the last question, here the region, the shadow of this region on the xy plane is this particular region, and we have also obtained this equation y equal to x and y equal to 1, and now we have to first find the limit of x here, and then we have to find the limit of y. First we have to find the limit of x, and then we have to find the limit of y. So from this region now we'll be finding the limit of x and y. So first we'll be finding the limit of x. To find the limit of x, we'll be drawing a line parallel to the x-axis. So observing this line, we will be now finding the limit of x. We see that this line enters this region at this point and exits the region at this point. So the limit of x is from this point to this point. So we get that at this point, this is a point on the y-axis. So any point on the any value of x on the y-axis is certainly 0. So this point, the value of x is 0. And this is point on the line. So we have already found the equation of the line from the previous problem. We have found that this equation is y equal to x. So y equal to x means the value of x at this point is x equal to y. So we get that the limit of x is from 0 to y. Now, now we have to find the limit of y. So we have to see that we can, this line L covers this region when we shift this line from this point to this point. So we see that this line L covers this region if we shift it from this point to this point. So the value of y at this point is 0. The value of y at this point is 1. So we get the limit of y from y equal to 0 to y equal to 1. So now we shall substitute all these values: 0 to y minus x, 0 to y, 0 to 1, dz dx dy. So now next we are having second question. So our graph is still the same, only our shadow may change. So our second part is we have to find triple integral dy dz dx. So we have to write this in triple integral properly. So to write this triple integral properly, we have to get the limits of integration. So here we can see that first we have to find the limit of y, then we have to find the limit of z and x. So to find the limit of y, we have to first consider a line parallel to y-axis passing through our region. So this is our region, tetrahedron, and we know this equation, this plane equation is y equal to x plus z, and we have to now find the equation of this also. equation of this particular plane. That also we can find by the same formula that we have used earlier, equation of the plane passing through 3 points. So, so this is, so we see that we have to first find the limit of y. So to first find the limit of y, we'll be considering a line passing through the region parallel to our y-axis. So this is our y-axis. Parallel to this y-axis, we consider m. Now this m will determine the limit of integration for our integral. So we see that this touches, this line m touches our region at this point and exits our region at this point. So these 2 points will determine our limit of y. So we see that we have to find the equation of these two planes. Only then we can find the value of y from those equations. So as I have told, we will be using the equation to find the equation of the plane passing through 3 points, x1, y1, z1, x2, y2, z2, and x3, y3, z3. So by using that, we'll be getting equation y equal to, the equation of this plane will be y equal to x plus z, and the equation of this plane will be y equal to 1. So we get that at this point the value of y is x plus z, and at this point the value of y is equal to 1. So we get that the limit of y is from x plus z to y equal to 1. Now we have to find the limit of z and x. So to find the limit of z and x, we have to project our region on the zx plane. So we have to project this particular region on the zx plane. So we have to first project these areas. So first we have to project these points. So this point will be, if here this point is 0, 1, 1, then the projection of this point on the z axis will be putting y equal to 0, y coordinate and x coordinate as 0, we get that this point will be 0, 0, comma 1. And in the same way here also this point is 1, 1, 0, and we have to project this on the x-axis. So projecting this on the x-axis means you will be putting the y and z coordinate as 0. So y coordinate is, putting y coordinate 0, we get 1, 0, 0. Z is already 0, so we have no issue. So this point will be 1, comma 0, comma 0. And this point is 0, comma 0, comma 1. This point is origin. So this particular region is the shadow of this region on the zx plane. So first we have to find the limit of z, and then we have to find the limit of x. First we have to find the limit of z, then we have to find the limit of x. So to find the limit of z, we will be considering a line passing through this region parallel to the z axis. And observing this particular line, we will be finding the limit of z. So we see that this line enters this region at this point, exits the region at this point. So the value of z at these 2 points will determine the limit of z here. So we see that here this is our origin, so, and this is our x-axis. So at this point the value of z is always 0. And we have to find the value of z at this point. But we don't know the equation of this particular line. So we can use the formula, but we know that this line passes through these 2 points, and this point is 0, 0, 1, and this point is 1, comma 0, 0. So equation of line passing through 0, 0, 1 and 1, comma 0, comma 1, comma 0, 0 and 0, 0, comma 1, by using the formula equation pass of line passing through 2 points. We'll be using that formula and we'll be getting our equation as z equal to 1 minus x. So from there we'll get the limit of value of z as z equal to 1 minus x. So we get z equal to 0 to z equal to 1 minus x. So the limit of z is from 0 to 1 minus x. Now we see that now we have to find the limit of x here. So we see that this line covers this region R if we shift it from this point to this point. So the value of x at these 2 points will determine the limit of x. So the value of x at this point is 0, this is our origin, and the value of x at this point is 1. So we get the limit of x is from 0 to 1. So now we get all the limits. So we will be substituting in triple integral dy dz dx is equal to the limit of y is from x plus z to 1, the limit of z is from 0 to 1 minus x, and the limit of x is from 0 to 1. So then now next we don't have to evaluate it, only we have to write the integral. So next is part C. So in part C, our order of integration is of the form dx dy dz. So again, our region is the same. So first we have to find the limit of x. So to find the limit of x, we'll be considering a line passing through this region parallel to x-axis. So this is the line passing through a region parallel to x-axis. So observing this particular line, we will be getting the limit of x in this case. So we see that the line is from this point to this point. The line enters this region at this point and exits the region at this point. So the value of x at this point, the value of x at this point is to be determined. So again we'll be using the formula. We have to know the equation of the plane, this particular plane, and equation of this particular plane. Only then we can find the value of x. So we see that this particular plane passes through these 3 points, and the equation of the plane passing through 3 points. We get an equation, we get that y is equal to 1. So we have to find the equation of this plane by using equation of the plane passing through 3 points. We know these 3 points, so by using this we have a formula for that, and by using that we get the value of x at this point is 0. And again by using the same formula, equation of the plane passing through these 3 points, we get the value of x here, that is x is equal to y minus z. So the limit of x is from 0 to y minus z. Now next we have to find the limit of y, and then we have to find the limit of z. So first we have to find the projection of region on the yz plane. So here we see that this particular point 0, 1, 1. 0, 1, 1 means x-axis is 0, y and z has some value. That means this particular point is in the yz plane. So if this point is in the yz plane, that means this particular triangle is in the yz plane only. So this particular plane is the projection or the shadow of our region on the yz plane. So by observing this region, now we shall find the limit of y and z. So first we have to find the limit of y. So we will be considering a line L passing through a region parallel to y-axis to find the limit of y first. So we see that observing this line, we will be finding the limit of y. So we see that this line enters this region at this point, exits the region at this point. So these 2 points determine the limit of y. So we see that at this point, again, if we don't know the equation of this particular line, we'll be using, we know that the line is passing through 2 points, 0, 0, 0 and 0, 1, 1. So we can use the formula that I have mentioned in the last problem. equation of the line passing through two points in a three-dimensional space. So by using that equation, we get the equation of this line is y equal to z. Similarly, here also we'll be using the same equation of the line passing through two points. So simplifying, we get the value of y equal to 1. So we get the limit of y as y equal to z to y equal to 1. So the limit of y is from z to 1. Now we have to find the limit of z. So to find the limit of z, we will be observing this line. We see that this line will cover the region triangle only if it is shifted from this point to this point. If the line is shifted from this point to this point only, then the line covers the whole region. So we see that at this point the value of L is the value of Z is the value of Z at this point is 0 and the value of Z at this point is 1. So we get the limit of Z as 0 to 1. So now we substitute all the limits we have found. Triple integral dx dy dz equal to integral 0 to 1 integral z to 1 integral 0 to y minus z dx dy dz. So we can evaluate any integral, double integral dz dx dy or double integral dy dz dx or triple integral dx dy dz. We can evaluate any of the integral mentioned here. The value will be the same, that is 1 by 6. So thank you all. The next question I'll be discussing in the next video. Thank you.